Alright, the next topic is using pi theorem to calculate pi terms. Okay, so right here we're given a tubing. So we're looking for pressure difference. Pressure difference has 4 variables used to get the difference. You can have velocity, radius of bend, diameter of the piping, and rho, so density of the fluid, any arbitrary fluid. Okay, the way pi theorem works is the number of terms, pi terms you're going to have is equivalent to your number of variables, 1, 2, 3, 4, 5 variables, minus, we're using MLT in this case, so the number of dimensions, ML and T, 3. And is equal to 5 minus 3, which equals, it's going to be 2 pi terms. Okay. For pi term number 1, you're going to find your 2 dependent variables, okay? You know there's going to be 2 dependent variables. We know it's going to be the pressure difference is dependent and your radius of bend is going to be dependent, okay? So we'll do pressure difference first. So we'll have delta P times, now you do your other variables that are left, so V, D, and rho. We're going to do V to the A, D to the B, and rho to the C. Now right here I've went ahead and I've wrote their MLT dimensions. You can just get these from the table, MLT or FLT, whichever system you use will get you the same answer. Okay, so now I'm going to go to the next page to write their dimensions. So we're going to have pi term 1 is equal to the dimension of delta P, ML to the negative 1, T to the negative 2, L to the negative 1, T to the negative 2, times the dimension of V, so LT to the negative 1, to the A, then we're going to have the dimension of D, which is just L to the B, then the dimension of rho, which is ML to the negative 3. L to the negative 3 to the C. Now, what you're going to do is these need to be equal to dimensionless, in which case that will be M to the 0, L to the 0, T to the 0. Okay, so now you have an equation, you have variables with coefficients. You're now just going to use equating coefficients like you would in calculus. So first we will do M. At M, you look at the exponent. M's exponent right here is 1. So you're going to have 1 plus, you don't see an M again until this term, in which case it's 1 to the C. So C on this end is 0. 1 plus C equals 0. L, negative 1, 1 to the A, so plus A, 1 to the B, plus B, negative 3 to the C, minus 3C is equal to 0, and T, negative 2, negative 1 to the A, so negative A, MLT, that's all we got, and then 0. Okay, this implies we just solve equations at this point. C is equal to negative 1. This implies that A is equal to negative 2. And this implies now that we have negative 1 minus 2 plus B plus 3 is equal to 0. This implies B is equal to 0. Okay. Now that you know these, you're going to go back to your original one. Remember your units of length. So now we're going to go back to your delta P. This is now times LT to the minus 1, length over time, that's velocity. To the A, we know that's a -2. L to the B, but B is 0, so that term is gone. And then this is your rho. To the C, just -1. This implies that your pi term 1 is equal to delta P over V squared rho. Now your pi term 2 would be just the same. I'm just going to set it up. I'm not going to finish it though. The only difference is now you've already used one dependent variable, so you'll move on to your next one. So you would use R, D to the A, D to the B, rho to the C. You'd use your same units of length up here, except you'd use your R unit of length, which will be L. Yeah, I can do it quickly, it'll be fine. Okay, we would have L times LT to the minus 1A, LB, ML to the -3C. These are all equal to 0. We'll equate coefficients quickly. You would have M, just one M, it's just C. So you know C is equal to 0 already. L, L to the 1, L to the 1A, L to the B, L to the -3C, equal to 0, T, -1A, which is -A, is equal to 0. So we know both A and C are equal to 0. Only variable here is going to be B. That's 0, that's 0, B equals -1. So now real quickly, since A and C are 0, we know V and rho are going to be gone. We're just left with R, D to the B. So we know our pi term 2 is equal to R, D, B was -1, which is equal to R over D. So there are your two pi terms.